axis. This chapter is designed to give us side view of the topics like a position vector, Dirac delta function, coordinate system, delta operator, its operation like gradient, divergence, and curl. It also give a view of fundamental theorems which are going to be used further, and line, surface, volume integrals. Position vector. Position vector. Let a point P to be exist in Cartesian coordinate system. Then its position with respect to the origin O is called the position vector r cap. This position vector has value magnitude is equal to the length from O to P and the direction from O to P. Dirac delta function. Dirac delta function is a function defined by the following property. Now what it says that delta function does not exist anywhere when x has a different value, but it exists when x equal to 0 and it has a value as a infinity. Means at x equal to 0 delta exists. Therefore, when we find integration on x-axis from minus infinity to plus infinity, Dirac delta function dx, it comes out to be 1 since it exists at a single point, but it does exist in a x-axis. We will see some of its property. Let's suppose if we multiply Dirac delta function with a constant a. That means Dirac delta function is equal to minus infinity to plus infinity Dirac delta function dx is equal to a. That means at x equal to 0, the all constant exists. Otherwise, the constant does not exist. Now, since the Dirac delta function is used extensively and has some useful and slightly peculiar properties, it's worth considering these points further. Now, for example, if we consider f of x a function of coordinate x to be integrated, then we have minus infinity to plus infinity f of x Dirac delta function into dx. When we multiply f of x with the Dirac delta function, it does exist, but at x equal to 0. That is, when f equal to have the value at x equal to 0. Second property which we are going to see of Dirac delta function is the shifting property. Again, we have the same function f of x, but this time we wanted to shift. We don't want that f of x to be exist at x equal to 0. We want f of x exists to be x equal to some specific value, some other value apart from the 0. Let's suppose I wanted f to be exist as x equal to a. That means if we make Dirac delta functions shift from 0 to x equal to a, that means if I write x equal to a, that means x minus a equal to 0. As a result, the figure shows that it does exist when x equal to a. This type of property of Dirac delta function is known as shifting property. Coordinate system. In this heading, we are going to see three types of coordinate system: Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. In Cartesian coordinate system, or you can say rectangular coordinate system, the point P is represented by the coordinate x, y, and z. Therefore, OP, vector OP is the position vector of P with respect to the origin O is equal to x I cap plus y j cap plus z k cap. Here I, j and k are the pointing vector or unit vector pointing in the direction of x, y and z. These vectors are orthogonal. Cylindrical coordinate system. In cylindrical coordinate system, the point P in a space is represented by order of three triplets, that is r, theta and z, where r and theta are the polar coordinates of the projection of point P in xy plane, and z is in the direction as a directed from the xy plane to the point P. Now, to convert cylindrical coordinate system in Cartesian or Cartesian coordinate system into cylindrical, we have a 6 equation. X equal to r cos theta, y equal to r sin theta, z equal to z, or r equal to under root of x square plus y square, tan theta equal to y by x and z equal to z. Spherical coordinate system. Now, in a spherical coordinate system, the point P is represented by again by the triplet r, theta and phi. Now, r is the distance of point P from the origin O, and theta is the angle same as a cylindrical coordinate system, where phi is the angle between the z axis and the line segment OP. Now, the connection between rectangular and spherical coordinate system is shown by this 6 equation, where x equal to r sine of phi cos of theta, y equal to r sine of phi sine of theta, z equal to r cos of phi. Similar way, r equal to under root of x square plus y square plus z square, tan of theta is equal to y by x, and cos of phi is equal to z by under root of x square plus y square plus z square. Operators. Delta operator. Delta or nebula is an operator used in mathematics, in particularly in vector calculus. Strictly speaking, delta is not a specific operator, but rather than a convenient mathematical notation for the three operators gradient, divergence, and curl. We will see how the delta function will look like in the three different coordinate systems. Now, consider a point in the Cartesian coordinate system. Let's consider a small, infinitesimally small volume element across the point P. Let point P to move. The rate of change of volume element will be by taking the partial derivative. In the direction of x, we will have deba by deba x I cap. In y direction, we have deba by deba y j cap. In z direction, we have deba by deba z cap, k cap, and that result into the delta as delta equal to deba by deba x I cap plus deba by deba y j cap plus deba by deba z k cap. Consider a point in cylindrical coordinate system. And now you consider a small elements, volume elements across this point. Now let the point move. So the rate of change of taking will be found by the taking partial derivative of the coordinates. Now deba by deba r cap is in the direction of r. 1 upon r deba by deba phi cap in the direction of phi. 1 upon deba by deba z k cap in the direction of z. In a spherical coordinate system, consider point P. Let consider a small volume element across this point. Now let point to be moved so that the rate of change of volume element will be again taken by the partial derivative of the coordinates. Now here we have as a theta, phi and r. Therefore, in the direction of r, we have deba by deba r cap. In the direction of theta, we have 1 upon r deba by deba theta cap. In the direction of phi, we have 1 upon r sine theta dabba by dabba phi phi cap. Gradient. Gradient is the first type of operator used for the edge direction. The gradient of an image is a vector consisting of first order derivative. Let's suppose we have u of x, y, z, a scalar field of position vector r cap in a 3 dimension, and then it gradients to at any point in Cartesian coordinate system is simple. Gradient of u is equal to, as we have before seen, the delta function dabba by dabba x u dabba by dabba y of u dabba by dabba z of u caps. Divergence. Now, divergence compute a scalar quantity from the vector by the differentiator. Now, if v of x, y, z is the vector function in the 3 dimension, the divergence of the function will result in a scalar quantity like this. Divergence of vector v is equal to dabba by dabba x of vx dabba by dabba y of vy dabba by dabba y of vz. Curl. The curl of vector field A, denoted by vector A or del cross A, is a vector whose magnitude is maximum net circulation of A per unit area as area tend to 0, and whose direction is normal to the direction of the area. So according to the Cartesian coordinate system, del cross A, that the curl of A, is equal to module of ijk determinant of ijk dabba by dabba x dabba by dabba y dabba by dabba z ax ay and az. Fundamental theorems. Here we are going to see 4 types of fundamental theorems. 1 from the calculus, 3 from divergence, curl and gradient. Now, this calculus theorem is actually not basically the vector theorem, it's a fundamental theorem of calculus. A statement said that integration of a derivative over interval is given by the value of the function at the end position, that is the boundaries. Now suppose f of x is a function of one variable, okay. Therefore, from point A to B, f of x dx is equal to function f A to B, that is function's value at B minus function value at f A. That means it completely depends upon from where you started and where you ended the function. Does that depend which path you follow or which shape is the thing? It's only depend on the boundary condition, on the boundary lines, points. Now, same function when we see in a gradient. Now, this function what we talk about is only for one variable. Now, if we take three-dimensional variable, that is fundamental theorem of gradient. The integral of derivative is given by the value of the function at the boundaries. Now, suppose the scalar function, which is of 3 variables, that is x, y, and z, independent variable. Therefore, the gradient of p from point A to B dl is equal to its value at final minus its value at initial. And remember that this is now not x, not y, not z, on 3 of variable. You have to find the gradient first and then you have to integrate it to find the final value. Divergence of the function. Fundamental theorems of divergence. The integral of derivative of divergence of a function over a volume is equal to the value of a function at the boundary of the surface. That means over the volume, if we find the divergence of V, which is equal to integration over a closed surface V dot dA. Fundamental theorem of curl. Statement. Integral of derivative curl of a function over a surface is equal to the value at the boundary of the closed line or closed path. That means integration over a closed surface del cross V is equal to integration over a closed path V dot dl. Solid angles. Solid angles is equal to d omega is equal to dA, which is a vector at the surface, vector dA dot r cap divided by r square. Now dA is what? Actually n cap r cap divided by r square dA. Now this n cap r cap has a value of 1 since it's a unit vector, magnitude value is 1. But there is an angle between these two vectors, that is theta, cos of theta. If we consider the whole dome of cos of theta, that means integration over close angle cos of theta, and that result to theta is equal to cos of theta is equal to 1 and theta equal to 0. This angle and r cap both directed in one direction, and the integration remains only on the area. This whole area is nothing but the circumference, that is 4 pi r square. Therefore r square get cancelled. What remains? Only 4 pi. Solid angle is equal to, no matter which type of body you are using, if you are finding a solid angle, whole solid angle, then it is 4 pi. Now del dot r cap divided by r square. The divergence of r cap divided by r square is 0 for all value of r when r is not equal to 0. But at r is equal to 0, we have it as a Dirac delta function. It's the corollary of Dirac delta function. The del dot divergence of r cap divided by r square is 0 everywhere. But it does exist only when there is a Dirac delta function 4 pi r Dirac delta function r cap. Line integral, surface integral, and volume integral. Line integral. Let A is a vector. A is ax cap, ay cap, az k cap. Be a vector function of position, defined and continuous along a path. The line integral of any tangential component of A along the path C from the point P1 to point P2 is written as like this. Now dr is also dxi cap plus dyz cap, dyj cap plus dz k cap. Infinitesimal displacement vector. When we substitute the value of a cap, a vector a and dr vector in the equation, we resulted into I cap equal to 1, that is ax dx, j cap equal to 1, that is ay dy, k cap equal to 1, that is az dz. The value of a line depend upon the critically on particularly path taken from point A to P1 to P2. But there are special cases of vectors function for which the line integral is independent of path and determined entirely by the endpoint, as we have seen in the fundamental theorem of divergence, gradient and calculus. Surface integral. Now, surface integral on an expiration of the form integration over a closed surface V dot dA. Now, V is a vector function, dA is an infinitely small area, small patch with the direction perpendicular to the surface. Okay, volume integration. Volume integration is an expression of the form integration over the volume vector t tau d tau. Now this d tau is dx dy dz, whereas vector t again dx I cap, t by z cap, dz k cap in Cartesian coordinate system. When we multiply it, we will have integration of tx component dx I cap, integration of ty component dy j cap, integration of tz component dz k cap. And my bibliography is only the graphic.